At the same time that you are viewing this, significant portions of the astronomical community are actively participating in the largest treasure hunt that has occurred in more than 100 years. A massive object, the presence of which has only been detected indirectly through its gravitational attraction on smaller things, is thought to be hiding on the outskirts of the solar system. This thought has led to the possibility that the object is present. This object, on the other hand, may soon be viewed directly, which would then show a planet that had not been observed before. This planet would be the first new member of our cosmic family in recent memory. Since its suggestion in 2016, the hypothetical planet, which has been given the imaginative name Planet 9, has been gathering support, leading some people to fear that we may soon need to rewrite the entire history of the solar system in light of the growing evidence that it exists. At the very least, this is the dream that astronomers are clutching to like a pot of gold the size of an airplane, the cosmic rainbow that they are trying to find. On the other hand, as we will see in the following section, the scientific community still has a great deal of uncertainties regarding Planet 9. It is possible that it is something that is entirely out of the ordinary, or it may be the next major thing that humanity discovers. Welcome back, space enthusiasts, to another mind-blowing episode of Spaceverse, where we unravel the mysteries of the cosmos. Join us as we delve into the latest research, explore cutting-edge theories, and follow the trail of clues that may lead us to the discovery of Planet 9. Don't forget to like, subscribe, and hit that notification bell to stay updated on all things space. Let's get started. In a strange turn of events, the idea of a ninth planet was put forward at the same time that astronomers formally reduced the number of planets to 8. It was the beginning of the new millennium, and with it came a flurry of dispute and a steady stream of discoveries about the outer reaches of the solar system. To begin with the discoveries, the Kuiper Belt is a ring of objects that extends beyond the orbit of Neptune and contains frozen bodies. In 1992, scientists finally demonstrated that the Kuiper Belt exists. The enormity of a handful of these remains, on the other hand, did not become obvious until the turn of the century passed. But in the years 2002 and 2005, scientists were led by Mike Brown in the discovery of 6 dwarf planets that were considered to be serious rivals for the position of Pluto. This latter piece of information generated a stir due to the fact that the mass of one of the recently discovered dwarf planets, Eris, is greater than that of the 9th planet, which has now become extinct. The possibility that Pluto is not really a planet at all has just recently been brought to the attention of scientists. Particularly noteworthy is the fact that this led to a conference of the International Astronomical Union in 2006, where the decision to declassify Pluto was narrowly approved. Amidst student frustration reworking solar system models for the science fair, hints surfaced suggesting Pluto wasn't the only planet. There were suggestions of a larger celestial body, despite Pluto's size disqualifying it as a planet. The first indication came from Sedna, which is one of the dwarf planets that have recently been proposed. Sedna exhibited behavior that was distinct from that of other objects inhabiting the Kuiper Belt, including as Pluto, Eris, Haumea, and Makemake. It had a peculiarly extended orbit that lasted for more than 11,000 years and took it from an extremely near closeness to the Sun of 84 astronomical units, AU, where 1 AU is the distance from Earth to our star to its farthest point of 937 AU. This orbit took it from its closest point to the Sun to its farthest. People once saw Sedna as an anomaly, a peculiar planet behaving uniquely on the solar system's outer edge. On the other hand, when we discovered and investigated an increasing number of things in the vicinity, it became clear that Sedna might not have been the only one working there. The term trans-Neptunian objects refers to the very small frozen planets that are located directly beyond the orbit of Neptune. These planets are remnants of the solar system's construction. We believe that there could be hundreds of thousands of TNOs that are a distance greater than 100 kilometers, despite the fact that it is typically impossible to identify them. Up to this point, we have only discovered about 4,000 of them completely. We are able to see that some of them behave in a manner that is opposite to what our model of the solar system predicts, despite the fact that the sample size is rather small. To begin, there is the category of disconnected TNOs, which accounts for approximately 10% of the total. Despite the fact that our models anticipate that some of these dwarfs should exist, it is difficult to explain their non-Neptunian orbits due to the large quantity of them. Then there are a multitude of TNOs whose orbits are so wildly tilted that they circle the Sun at an angle that is greater than 45 degrees. This is yet another phenomenon that our models do not foresee occurring on such a massive scale. Last but not least, there are TNOs that move in such an unusual manner that they are sometimes referred to as ETNOs, which is an abbreviation that stands for extreme trans-Neptunian objects. Approximately a dozen of them are spread in such a chaotic manner that extra gravitational sources are required. This is probably what pushed them out of alignment a very long time ago and is now holding them captive in their odd dances. Mike Brown and Konstantin Batygin proposed an idea in 2016, a hidden world, possibly 5 to 10 times the mass of Earth, could be influencing Sedna and 5 other distant objects. All things considered, the 9th planet does not exist. In the 7 years that have passed since that proclamation that created a commotion throughout the universe, the concept has been refined. According to the most recent estimations, the mass of Planet 9 is closer to 6 times that of Earth than it is to 10 times, which suggests that the planet is substantially smaller than was previously believed. Furthermore, it has been discovered that 11 TNOs, rather than just 6, have been found to have been disrupted by its orbit. The fundamental premises of the hypothesis, on the other hand, have not been altered. One premise suggests a planet beyond Neptune, distinct from others, possibly overlooked despite advancements in planet detection tech. In light of the fact that there is another planet in that location, the next question that should be asked is, what is it like? In our solar system, the planets can be classified into one of 3 primary categories. The planets that are classified as rocky terrestrials are Earth, Venus, Mars, and Mercury. Another category consists of the gas giants, which include planets like Saturn and Jupiter. The remaining members of the ice giants are Neptune and Uranus planets that are classified as gas giants. Should you find yourself in a generous frame of mind, you might also consider include the dwarf planets on that list. Regardless of whether our solar system has 3 or 4 classes of worlds, the discovery of Planet 9 would bring the total to a higher level. However, this specific argument is not the most important one. The reason for this is that Planet 9 might be a rocky super-Earth or a gaseous sub-Neptune, given that its mass is probably somewhere in the center of that of Earth and Neptune. It would be an exciting adventure to find it regardless of the circumstances. Consider the range of feelings that paleontologists may experience if they were to find a mammoth creature that was still alive. Currently, the only artifacts that we have that pertain to these animals are those that date back to a very long time ago. The transition from studying abstract notions to researching a living being would be a mind-boggling one, to say the least. In the same way that they would feel if they discovered a sub-Neptune in our backyard, planetary scientists would feel the same emotions. It is very clear that the comparison is not perfect. Mammoths that are still alive are so uncommon that they are not regarded to be extinct. This is in contrast to the phenomenon of sub-Neptunes being found all around the universe. The information presented here should still be able to provide you with a broad idea of how incredible such a finding would be and how it could throw light on the riddles of planet formation in star systems that are both close by and far away. Sub-Neptune and super-Earth could not have originated in their current orbits because they are so far away from the Sun. This is the most crucial factor to keep in mind. A scenario in which it was born closer to the center and subsequently thrown outside during a time of instability brought on by Jupiter's early motions is the one that is more likely to occur. Others claim that Uranus may have originally belonged to another star before being pushed into our solar system by the gravitational attraction of the Sun many millennia ago. Some people believe that Uranus's distorted orientation is the consequence of a random meeting or collision with a planet that is in transit. It is quite clear that all of this is based on speculation, a big theory that is superimposed on a multitude of distant objects that are responding in odd ways. Nevertheless, this does not suggest that the tower is not constructed well. In point of fact, humans have been responsible for making key discoveries about planets in the past through the study of orbital disturbances. It is the discovery of Neptune that is the most well-known example of this phenomenon. Since the time when William Herschel first focused his attention intently on Uranus, it has been common knowledge that the orbit of Planet 7 was somewhat inaccurate. Presumably, a significant component was having an effect on it. In the year 1846, Sir Bain Leverrier was able to determine the specific location of the invisible item by performing the necessary mathematical calculations. Following his warning to a German astronomer, Neptune was discovered extremely late that very night. Regardless of whether it was done intentionally or unintentionally, this story highlights the value of recognizing abnormalities that appear to be of little consequence. An attempt is being made by contemporary astronomers to locate Planet 9 in the same manner as Leverrier did. That is provided that we have not discovered it up until this point. After further investigation, it was found that Pluto, Eris, Neptune, and Uranus had all been observed prior to their official discoveries. However, these observations were made by persons who were unaware of the real nature of these planets. Galileo, for example, is credited for recording Neptune in the year 1612, but he mistook it for a star. All of this is taking place at the same time as the discovery of a photograph of Eris from 1955. As a result, it is not completely out of the idea that there could be signs of Planet 9 already hiding in some data set that has not been recognized in the event that it does in fact exist. One of the potential candidates is the astronomer Michael Rowan Robinson, who in 1983 utilized the very first infrared space telescope for the purpose of conducting a planet hunting mission. Following the publication of Brown and Badigan's theory regarding Planet 9, he went back to his prior research, which he had initially disregarded as being fruitless. It was there that he found 3 possible matches for the planet that had been lost. But due to the poor quality of the detections, it is not possible to confirm which ones they are. At this point, our conversation for this chapter comes to an end. In light of the fact that we have a solid notion of the general location of Planet 9, you might be wondering why we have not yet discovered it after 7 years of searching for it. Sadly, it is extremely difficult, if not impossible, to identify a planet at such high distances, particularly one that is equal in size to Neptune. This is especially true for planets that are far away. However, Brown and Badigan have just made a profound discovery as a result of their efforts to improve their calculations. They have determined that instead of an orbital journey that would take more than 18,000 years, they expect that Planet 9 would complete 1 revolution around the Sun every 7,400 years. Because of this, visibility should be better than anticipated, as it should be both closer and brighter than anticipated. The information was amazing in theory. Reducing the orbit of an object by more than 10,000 years results in a significant reduction in the amount of space that the thing travels through. In spite of the fact that it would take an object more than 7,000 years to complete 1 orbit around the Sun, it is still capable of reaching distances that are incomprehensibly far from Earth. In order to give you an idea, the orbit of Pluto takes 250 years to take place. In spite of the fact that Sedna has an orbit that is 11,400 years longer than that of Planet 9, it was detected close to perihelion, which is the point in time when objects are closest to the Sun by Earth. In contrast, it is believed that Planet 9 is currently at its most distant position in the solar system. The search for such a minute object that is moving against the background of the star field of the Milky Way is a monumental task. Because it is so far away from the Sun and will reflect very little light, the missing world will be difficult to detect in visible wavelengths. This is because it will be so far away. Its emission is most likely restricted to the far infrared spectrum due to the extraordinarily low temperature at which it exists. Due to the fact that even the James Webb Space Telescope, which is incapable of detecting things in the far infrared band, will not be able to view it, the adjective far is extremely important. There are a number of difficulties that are specific to the viewing of very distant objects with infrared technology. Using information obtained from 2 infrared sky scans carried out 20 years apart, Cedric, Chris, and Sargent conducted a study that was published in the year 2022 in the journal Universe Today. In this investigation, they initially identified 500 potential candidates for the Planet 9. On the other hand, following closer study, they found that the vast majority of them were interstellar dust clouds that emit infrared radiation. These clouds are known as galactic cirrus. Any search would be plagued by such false positives because to the fact that it is believed that the Milky Way starfield is currently concealing Planet 9 at this time. These challenges aren't insurmountable, but they demand immense patience, extensive telescope time, and precise navigation. When we say that Planet 9 is currently moving against the Milky Way starfield, we are giving the impression that we are in a rough location. This can be fairly misleading. This location would be equally as unpleasant if you were to drop a stone from an airplane over the United States and state that it landed in the Midwest. However, despite the fact that it is correct in theory, it will not be of any assistance to anyone in their search for the stone. The problem, as described by 2 planetary scientists in an article published in Conversation, is that the range of vision of such telescopes is often rather limited. To put it another way, it is as if we were using a microscope to look through a huge area in order to find a small item that we had dropped. This gives light on the reason why multiple search parties have been failed to locate the missing person since 2016. Australia was nice enough to provide a list of some of the significant instruments and surveys that have been utilized up to this point. These include the TESS telescope, the WISE telescope, the Geospacecraft, the Dark Energy Survey, and the Catalina Sky Survey. Besides going over past data from surveys like the Zwicky Transient Facility Survey and the Sighting Spring research, we will also be looking at the results of such surveys. The search yielded no results. Also, since our understanding of the Kuiper Belt is limited, it is difficult to employ the orbits of transient nebulae objects, TNOs, that Planet 9 has disturbed to identify its specific location. After all, it is tough to draw judgments about entities whose behavior is so out of the norm. In the event that we are able to examine and comprehend the belt's full structure, we could be able to find locations in which a big planet has interfered with the creation of the belt. The fact of the matter is, however, that we are currently dealing with around 12 objects that, as a result of selection bias, might appear to be in strange orbits. In the event that this is the case, Planet 9 might as well not exist at all, existing only as an illusion that is produced by staring at a distorted and faulty image in the hope of finding something. In spite of the fact that integrating all surveys and blindly aiming telescopes at the night sky and hoping for the best are both successful strategies, there are alternative ways to locate a planet that has gone lost. If all goes according to plan, we will soon be able to pinpoint the precise location of our hidden neighbor through the use of some fairly inventive mechanisms. As stated in a song by Elton John, Planet 9 in fact is cold as hell. Mars is included in this statement. You are aware of something that could be a little bit warmer, right? The moons that revolve around a planet. Mercury and Venus are the only two planets in our solar system that do not have any moons. Jupiter is the only planet that has moons. In light of the fact that the region that Planet 9 inhabits is teeming with TNOs, which are the most significant gravity sources in the vicinity, it is quite plausible that Planet 9 is traveling across the void with some friends. It would be absolutely incredible if Planet 9 had managed to capture a few TNOs during the course of its history. Neptune is a good illustration of this. A large number of people believe that the ice giant's enormous moon Triton is actually a dwarf planet that was drawn into the orbit of the ice giant. Perhaps you are wondering why this is significant at this particular juncture. Because of its distance from the Sun, any moon must be just as frosty if not colder than its main planet, making it even more difficult to locate than the main planet. Perhaps it's not as horrible as you think. Acquiring of newer information, Man Hoi Chan, a researcher from the University of Hong Kong, has just published a preprint study that investigates the influence that tidal heating could have on any moons that may orbit around Planet 9. Even for those of us who are not experts in the field, the idea of tidal heating is really fascinating. It's thought that the heat-generating process, fueled by non-uniform gravitational forces, maintains subsurface oceans on moons like Triton, Europa, and Enceladus. Nevertheless, the most significant problem with the study is not liquid water, but rather the heat that would be produced as a result of this process. In the event that this is true, the moons of Planet 9 might be hotter than the planet itself, which would increase the possibility that infrared sky surveys will find them. The theory is intriguing, and it is one of the many audacious hypotheses that have been proposed in recent times regarding the ways in which people might be able to detect the world that is hidden from view. There is also the possibility of following the path of an interstellar asteroid, which is an even more comprehensive and extensive process. The accident of the CNEOS 8 January 2014 in 2014, which occurred offshore in Papua New Guinea, is the most well-known case of this vehicle. In the aftermath of this, a marine dredging operation led by Loeb, who is of the opinion that the meteor could be extraterrestrial machinery, started aiming for it. However, regardless of whether or not it is what Fox Mulder fantasizes about, it might have a very large number of other applications that are valuable. Researchers from the Institute Astrophysique des Canaries, Hector Socas Navarro and Ignacio Trillo Cabrera, assert that if we follow its path back through the solar system, we will be able to ascertain whether or not it collided with a big object. It was in the year 2023 when that very item was published in a paper. Inside, they presented the evidence that the asteroid most likely originated in the same region of the solar system as Planet 9, which was the subject of their investigation. Under the assumption that the planet does in fact exist, there is a probability of around 99.9% that the meteor will collide with the gravity of the planet. It is possible that we will be able to ascertain the precise location of Planet 9 at the time that the meteor was traveling through our solar system if we follow the path of CNEOS 14 in reverse orientation. According to Socas Navarro and Cabrera, the location of the missing globe is very close to the point where the constellations Aries, Taurus, and Cetus meet. Getting proof of this reality is like reducing the position of our airplane drop-off from the Midwest to somewhere in downtown Des Moines, to use our previous chapter's analogy. This is still a massive uncharted territory, but it's starting to feel more feasible. However, we may have a preference for the Planet 9 location mission that involves exploring Uranus. The most recent decadal survey ranked a NASA mission to Planet 7 as the agency's top goal. The craft will spend 10 to 15 years just traversing the space between Jupiter and its destination after it launches, if the US Congress can calm down long enough to resume funding science again. That decade may actually be quite useful to research rather than just a frustrating lull. We know an interplanetary craft isn't going to fly off course or activate any hidden monoliths, because every so often it calls an Earth station to let us know how it's doing and where it is on a lengthy voyage like that. Typically, you won't hear these pings very often. However, we might observe the effects of faraway Planet 9's gravity on the Uranian probe over time if we could get it to fire off sufficiently. It would be a small influence, a tugging that is almost invisible, but it would be sufficient for us to utilize that data to pinpoint the location of Planet 9, maybe even enough to persuade astronomers to begin directing big telescopes in that area, confident in their good chances of discovering something. And surprisingly, NASA will need a few more years before it is prepared to explore the grandeur of Uranus. That bodes well for the likelihood that we will have found a planet well in advance. One of the most intriguing scientific endeavors that are presently receiving little attention is the Rubin Observatory in Chile. This 8.4-meter telescope will take pictures of the whole night sky every few days, creating massive amounts of data that astronomers can use to seek for evidence of extraterrestrial objects. We will most likely find Planet 9 in this manner if it is indeed out there. Can we still proceed if it isn't? Imagine if when the Rubin finally goes online, all it returns is a black hole where the sub-Neptune ought to be. Surprisingly, that could be more thrilling than discovering it itself. The feeling that Planet 9 might be the world that Brown and Badigan speculated about in 2016, or it could be something entirely else, is perhaps the most intriguing aspect of the planet. You often come across pictures of ancient maps that depict what would have been Australia had it never been discovered. Regarding Planet 9, that is roughly the situation at the moment. We have a general idea of its location and that it exists in the world, but beyond that we could as well say there may be challenges. What then may Planet 9 be if it isn't a sub-Neptune or a missing super-Earth? A planet exists according to the first theory. It's just not the kind of planet Brown and Badigan had in mind. A sub-Neptune would have the strongest gravitational pull in the area according to models, which means it would disrupt the orbits of many more transient nebula objects than what we're seeing right now. Planetary scientists Patrick Leclerc and Takashi Ito postulated in a 2023 Astronomical Journal article that this could be the reason why Planet 9 could be smaller than Earth. Findings suggested that all the strange TNOs we know of could be attributed to a planet 1.5 times Earth's mass that orbits 250 to 500 AU from the Sun, particularly if its orbit is slanted 45 degrees. That would change Planet 9 from a secret behemoth to a real-life mess to a near-identical twin of Earth that was probably flung out into the frigid Kuiper Belt in the early solar system. But this is only the most reasonable interpretation. The most thrilling possible conclusion would be if Planet 9 is really a primordial black hole, which would be the most bizarre outcome up to that point. According to the idea that Stephen Hawking proposed in 1971, black holes could have originated in concentrated pockets of matter as a result of the harsh conditions that existed immediately after the Big Bang. It is possible that these early black holes originated from any location in the universe, in contrast to the ordinary black holes that are generated when stars collapse. It's possible that the objects are as big as planets, but they could also be much smaller, somewhere in the neighborhood of the size of a beach ball. Due to the fact that we have never seen any evidence of these beings, the thought that they may be hiding on the outskirts of the solar system is really exciting. In addition, we would be able to put Hawking's theory to the test by sending a probe to investigate such a black hole, which is something that we probably won't be able to do with regular black holes for hundreds of years, if not thousands of years. In the event that Planet 9 were determined to be a black hole, the exceedingly low probability of detection would be a significant disadvantage. Not only would a primordial black hole be so small that it could be carried in a backpack, but it would also be completely devoid of any light. In the Midwest, it would be more like searching for a single grain of sand than it would be to look for a marble that had been dropped. According to a report published on phys.org, gravitational lensing and gamma-ray emissions would be inaudible due to the fact that the object is so small. Today, however, we are faced with yet another circumstance in which the Vera-Rubin Observatory may be able to come to our aid. An article written by R.V. Loeb and Amir Saidi suggests that it is possible for small comets to come into contact with a primordial black hole on several occasions throughout the course of a year. In the event that this were to take place, the spacing between them would result in a brief flash of light that the observatory ought to be able to detect. The New York Times reported that Loeb had stated that our calculations show that the flares will be bright enough for the Vera-Rubin Observatory to rule out or confirm Planet 9 as a black hole within 1 year of monitoring the sky. At the moment, the year 2025 is the date that is predicted to mark the beginning of the telescope's routine observations. There are other possible theories, such as the idea that Planet 9 is a massive dark matter or the bare core of a planet that has been extinct for a very long time. That concludes our discussion on the enigmatic frontier of the solar system, a puzzle that has perplexed academics for 7 years and may persist as such for the foreseeable future. The prospect of an imminent groundbreaking discovery, akin to Urbain Le Verrier's prediction of Neptune's position, adds intrigue to our current era. On the other hand, it contributes to the overall frustrated nature of the game. Being aware of the fact that there is a significant mystery that has to be solved, something that people in the future will take for granted, but which at least for the time being continues to evade us, is a source of concern. The hunt for Planet 9 will undoubtedly be one of the most memorable searches ever conducted, regardless of what occurs over the next few years. This is something that we can say with absolute certainty. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.